Hello and welcome. In this session, we will analyze our diabetes dataset using Databricks. We will walk through the entire data analysis process from loading data to discovering meaningful insights with the diabetes dataset. The dataset contains medical information like glucose levels, blood pressure, BMI, which we will be using to understand diabetes risk factor. Let me first show you the dataset. And this is the data set we will be using. So let me just increase the size. As you can see, it has a few simple columns: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI. This is family correlation or diabetes pedigree function, age and outcome. One means has diabetes, zero does not have diabetes. So let's get started. The first thing is to do is to upload this file to our database. To do so, click on New and go to Table. Inside Table, you will see an option for Upload File. Let's upload the diabetes dataset. And the next thing we have to do is open this in a notebook. By default, Databricks will give us a few commands we can use to run, but we will not be using them. Let's just delete all the cells and create our own cell. Let's rename it diabetes, select the language as Python, and let's also select our compute to the cluster. The first thing we will be doing is setting up the environment. Here we will import all the necessary. Here I will be adding the commands to import everything we will be needing in this. And that includes pandas, seaborn, matplotlib, skyline processing, and standard scalar and stats. Let's run this. This is the setting of the environment. No need to go very deep into it. And as we have already loaded our data set, and this is the first cell. Now let's do the programmatic loading of the data set that we just uploaded. Use the command yes, df equals to spark dot dot csv, and in here we will give the file path. Right, so let's leave it at that. Slash tables slash dot csv, and equals to true, and schema also true. And in the next line, let's give this a name, panda df equals to df dot pandas and display. So what will this be doing is it will load our data into a data frame and display the first few rows, basically the first file. And here you can see the same data set we saw in the .csv or the Excel file. Now let's get started. The first step we will be doing is data cleaning and transformation. This will examine our data and clean it. here you can see the first query we are using. And here we are printing dataset info as part as df info. This will give us as the info. This will also list the missing values such as which are null and or is entered zero, and this will give us the number of values which are zero. So let's run this. So as you can see here, there are 768 non-null values and 8 null values. Let's maybe zoom out a little bit. See, there are 768 entries and each of the data type, and there are some missing values. Missing values in uh, how do you say healthcare data set means that doesn't mean that these are values as zero, like BMI of somebody cannot be zero or insulin level can also not be zero. So this means that these are the missing values in the data set. And here as you can see five missing values for glucose, 35 for blood pressure, 27 for skin thickness and others. Now let's handle those zeros. So what we will be doing is replacing those zeros with the mean values in the data set, not necessarily changing the CSV file, but in the Databricks environment. So let's use for column glucose. So what this will be doing is replacing the zeros or the missing values with median value. Why the median value? Because mean has extremes, median does not. So let's just run this. And our missing values are now exchanged. Now let's go to the next step. And the next step will be the feature scaling. So we are using this. So what this will do, or the standard scaler will do, is standardize features by removing the mean and scaling it to unit variance. And let's run this. So this will put all our features on the same scale. This is crucial for many machine learning algorithms and for fair comparison between features. Now let's go to the next cell. In the next part, we will be visualizing our data to understand understand patterns and relationships. So we will be using C1 as we have already imported this, so we can delete this. So what this will do is create a histogram plot for each feature. Let's run this and let me zoom out. As you can see, we are using a 3 by 3 grid of subplots. Each histogram shows the distribution of values. The colors show the split between diabetic and non-diabetic patients. This helps us see which features have different patterns for diabetic versus non-diabetic patients. Now let's go to the next cell, and in this we will be creating a heat map. So let's use PNP. Zoom in, 350 is fine. Let's run this. So heat map is very powerful visualization, and red color show positive correlation and blue show negative. In here it's gray. So the darker the color, the stronger the correlation, and you can see how each thing affect. The number shows the exact correlation. This will help us identify which features are most strongly related to diabetes. As you can see from here, age and glucose levels are very high in this factor. Now let's go to the next cell. The next function we will be performing is creating a box plot. Let's run this. So it will show us the distribution of key features for diabetic and non-diabetic patients. The line in the middle of the box is median, and you can understand from this plot how each factor affect the diabetes outcome in people. Now let's go to the next cell. What we are doing next is statistical analysis to understand who's more likely to get diabetes. So let's just print. So this will show us the average values for each feature separated by diabetic and non-diabetic patients. And we can see which features tend to be higher or lower in diabetic patients. So as you can get from the data present here, in non-diabetic, and this is percentage basically. So negative percentages include lower data, meaning that these people did not have diabetes. So let's move on to the next step. Now we will calculate the correlation with outcomes. Uh, So this will show us how strongly each feature correlates with diabetes. So glucose at the highest and blood pressure at the lowest. Now let's move on to the next step, next cell. So what we will be doing in here is statistical tests, or basically the t-tests or the p-tests. We just add this code. This will give us the statistical test outcome. Let's run this. And here we compare each feature between diabetic and non-diabetic groups. The t-statistic shows how different the groups are, and the p-value shows if the difference is statistically significant. The t-values closer to 5 indicate significant differences. You can take a look at this data on your own. Now let's do some additional operations, such as the first thing we will be doing is additional analysis to get more insights. Let's use print pandas df describe. So the describe function gives us key statistics, count of values, mean, standard deviation, minimum and maximum values, quartile values for each feature. You can get from the data present here. Now the next analysis will be the value counts for diabetes outcome. Let's use print pandas df. So this will show us the proportion of diabetic versus non-diabetic patients in our data set, and the normalized equals to parameter gives us the percentage instead of raw counts. So you can see around 34.89% are diabetic and 65.1% are non-diabetic. Now we will be doing analysis or the age group analysis, meaning that this will create a age group for analysis that how many people below and above what age are diabetic. So let's write the command query. That's fine. And let's print. So this will create age groups from continuous age data, and there is some issue. I seem to have missed an equals. Now it should work. So this will give us an age group for data that how many people from what age group. There seems to be some other error. There was some error with my query. I have corrected it. Now you can see that it's according to the age group, and bins is to cut the age, and labels are just the labels for the outcome of the data. This groups the diabetic patient data set according to the age factor and how many people are affected by diabetes in each age group. So you can see age is a direct correlation with diabetes. Well, that's all for this session. Let's summarize our key findings. And so you can see from the analysis we performed, glucose levels showed to be the highest correlation with diabetes. BMI endings are also significant. We have seen how to properly clean and analyze medical data. These insights can be valuable for early diabetes detection and prevention. These techniques we have covered today can be applied to many other data analysis as well. Thank you for this session.